Hello. Once again, I'm Dr. Gifford, Superintendent of the Dartmouth Public School System. And I'm really excited today because we are on location at the Dartmouth High School. And we're in Mr. Sam Brodsky's room. He is our engineering and robotics teacher here at the high school, and we've got a lot to talk about. So here we go. Thanks for joining me today.
Great to be here.
Absolutely. So one of the first things before we get into looking at some of the really cool stuff you have around here, tell me about the Dartmouth High School engineering program. What are we doing? What's it look like?
Well, it's big and getting bigger. We started out, when I came down here, there was barely enough classes for one teacher. We are overflowing 2 teachers now. 3 rooms, 250 students a year, and a lot of students come through here. There are 3 levels. We have an introduction to engineering, engineering 1. We also have a robotics program, which is open to anybody. Anybody can take those classes. Then we have more advanced levels that you can take after you've taken those introductory classes.
Okay, really good. So it is growing.
Oh,
really
very fast,
growing.
yes.
That's
Actually,
awesome.
we have way more people sign up for the class than we could possibly teach.
Okay, I guess that's a good thing, but a bad thing. So we'll have to see what we can do.
Yeah.
So tell us about some of the tools that you use in your classroom.
Well, my favorite tool is right here. It's the saw stop that the PTO bought for us 3 years ago. And it's the safest tool, if you can imagine that, I have in my shop. It will not cut flesh. If your finger gets to where it will be cut, brake stops it in 1/8 of a microsecond and it won't cut you. We did not intentionally test it, but it did get tested one time and it did work. It was pretty amazing. We have a number of other, you see a lot of woodworking tools around the shop. I have a CNC router over here, which is not in great shape. It's pretty old. I found it in the closet, but it does work now, sort of, on ancient computers. But we were hoping to upgrade that at some point.
So what exactly does that do?
So the students, if they've taken Mr. Martin's class, they've learned to draw things with CAD. They're using SolidWorks or AutoCAD. And having drawn it on the computer, we can send it to that machine, and it will follow a machine code to cut it out of a solid piece of wood. It's really neat, labor-saving, and cutting-edge technology, at least if it was a little bit newer. But it does work, and that's the important part.
Okay.
This is an example of a project we made with that. So the biology department wanted a way to attach a cell phone to a microscope. So we came up with this device, and it's actually a pretty simple cut, but we need the machine to be this precise. So that just drops on there. It has 2 holes because some of them are 2-hole. And then you can set your phone up so that,
It's on.
there we go. Takes a little bit of doing.
Okay.
But once you get it just right, it's really nice because you can, instead of trying to stare through this thing and figure out what you've got, you can take a picture of whatever you're looking at in the microscope or even a video and then label that. So if you had 15 different slides to look at, you could label them and show that directly to your teacher or put that in your report or whatever.
So other than that, what are some of the most impressive projects you've seen happen or come out of this classroom?
I've had some really great ones. 2 years ago, I had someone tell me they were going to build a welder out of an old microwave. And that was one of those projects where I was like, yeah, sure, no problem. Like, I don't even have to worry about it. Don't have to worry about safety because you'll never do it. And then he did it. So we had to figure out how it was safe to use a welder, but it was pretty amazing. An old microwave can turn into a working welder. My favorite project is the RC planes. And this is the first one we started making last year. Like a lot of the projects, the ideas come out of different places. Different people had the idea to make these. I've been wanting to do actually drones. So then there's kind of 3 pieces. We have to come up with a good project, come up with funding, and the DEF came through with funding to buy all the initial equipment. And then lastly, I have to find somebody who actually knows how to do it because I'm not an RC plane guy myself.
Sure.
So I connected with the Bristol County RC Club, and these guys, Ned Watts, John Beer, and Chris Ferreira, have been coming down weekly and helping us build. Last year we built a class set of these, which was really fun, and flew them on the baseball field.
And it's just a styrofoam kind of thing.
It's made out of the same stuff you use to insulate houses.
Oh, okay.
I buy it at Home Depot, super cheap, and it was really cool. This year I kind of stepped it up and let students come up with their own designs. So we had, different designs, some of which have crashed and are no longer here. But monsters like this, right?
I love
which kind of flew pretty well.
Yeah.
Amazing things like this. Like this thing flies
really?
Incredibly
And you
well.
wouldn't think by looking at it.
Yeah, this is an amazing, partly because the student who's flying it, Derek Botello, I don't know if you know him, really impressive work and piloting skills. And then, this is actually a seaplane. It's supposed to land and take off from the water.
Right.
So it's been even better to open it up and have people come up with their own unique designs and get them out on the field, battling each other, flying around, chasing crows, whatever.
Right. And of course, part of it is, imagine what we're teaching is the engineering process. So, or the design process. Like, kind of talk about that.
That's the main thing that we're trying to do. It's, if I was teaching a class on like how to build a trebuchet, how to build an RC plane, it's not all that applicable to real life. But what I'm really trying to get across is how to go through a design process and create something, and at the same time keep track of what you're doing. If you're an engineer, that's really what you're going to have to do is not only design something, but keep track of it and then be able to report out about it to people who you report out to. And we do a lot of different projects, and we get to teach a little bit of physics here and a little bit of electricity or biology here or there, but or chemistry even, but
and some
mainly
math, I'm sure.
and some math, but mainly it's about the engineering design process and how to come up with an idea, find a goal, do research to figure out how to do that thing, come up with a plan with sketches, with dimensions, build whatever it is, which is sometimes the hardest part, test it and then output,
and also experience failure.
And
go
try again.
Back to exactly.
Right, and that's one of the biggest lessons is that the best designs aren't the best thought out.
Right.
They're the first ones that finish because they're able to fail once and try again and fail again and try again.
Right, exactly, and that's what we want kids to be able to grapple with stuff. So, the kids come down, students, and obviously those that continue to take a lot of these classes, the progressions. What are we preparing them for?
So, I'm trying to introduce them to a lot of different fields of engineering so that if they were to choose to go into engineering, they'd have an idea of whether they wanted to go into an electrical, chemical, mechanical field. In addition, not everybody is looking to be an engineer, and the world only needs so many engineers, but we need even more technicians than we do engineers. So a lot of students might not end up with a 4-year engineering degree, but they could end up with a 2-year associate's degree and go on to be a technician for some of the same companies.
Sure, good. Well, I'd love to see, I think we have something that we want to show that the students have been working on.
For sure.
So we're going to take a look at that.
All right.
So Ashley, you have your team here. Tell me about your team. What are your teammates' names?
This is Ethan.
Okay.
This is Chris.
Chris.
This is Leland.
Ethan.
And this is Xavier.
All right, good to have you guys. Thanks for joining us today. So this is a robot which you all have built, right?
Yes.
Is this robot have a name?
It's named the Hoff after David Hasselhoff. One of our former members loved David Hasselhoff, so we decided to name it after.
Okay, sounds good to me. Sounds good to me. So how did you come about building this? This is something you did, this team right here?
Yes.
Okay, how long did it take you?
It took us, this isn't the robot we started with.
Yeah.
We had a very different idea as to what our robot was going to do. So over like a few months, like I said, like 3 months, we ended up with this robot. So.
Okay.
Yeah.
Okay. So did you take this robot into a competition?
Yes, we did.
And how did that go?
It went pretty well. We ranked in 5th place. So, which is much better compared to last year coming in last place. So, yeah.
Okay, last to fifth is pretty darn cool.
Out of 20 teams.
Yeah, that's
so,
awesome.
Yeah.
That's awesome. I know I was able to come to something here. It was one of the first ones, I think, with Legos and things. So I was able to see that. So I'm sure it's kind of like that.
Yeah.
So each year, when you're involved in the competitions, do you use the same robot over and over, or what happens?
Well, this was like our first same team consecutive. So me and Ethan have actually been on the team for 2 years.
Okay.
So we decided to start from scratch because our old robot wasn't that good. So we're probably going to start from scratch this
Yeah.
upcoming season.
Yeah.
So
I bet you have a lot of new ideas that you would want to do anyway,
Yes.
right? Something you've learned from, I'm sure. And what grade are your teammates in?
I'm a junior, so is Xavier and Chris. Leland is a senior,
Okay.
and Ethan is a sophomore.
All right. So what else do you guys do as far as anything else you're doing in the school system or whatever?
We do outreach. We actually went over to DeMello to mentor some of their robotics kids. We went to DeMello night and we let little elementary schoolers build robots. That was pretty fun.
Nice.
And we're also showing off our robot at the event Thursday night.
Right. Oh, at the art and technology event.
Yes.
Which will be. You guys will be in the
Yes, we will be
cafeteria,
there,
I
yes.
think, here at the high school, and that will be a pretty cool thing. Hopefully, everybody will be able to come to that. So you'll be there. I'm happy to see because I'll be coming. So I want to ask you another question about the elementary schools. How much more do you think you might be able to work with them, or that you're already working with them?
Well, I hope to work with them in the future.
Yeah.
More, so.
Yeah, it's good. We want to see the program and what we're doing along this lines certainly grow. So, well, let's take another look at this guy moving around. Can you do something with him?
Actually, do you want to explain what it's supposed to do?
So it's supposed to climb up the mountain.
Right. And you had to program this.
I
part
didn't
of
program
someone.
it. Andre Pyers actually
Okay.
programmed it. So
So that's what I mean. You all, some students build it. It's a team effort, and the program is part of it. Programming.
Try it.
Yeah.
You have the treads there.
Love it. Love it. Awesome. All right, so here we are at another project that your students have designed. So tell us about what this is.
Well, again, it's a project that's a collaboration. A lot of these ideas come from me, but a lot of them come from students themselves. And in this case, it came from a teacher who asked if we could design a standing desk. So we came up with, it was a great project because I don't get to do a lot of production.
Right.
We often take the engineering process just as far as design, and then it's over. But here's a situation where I get to actually build them. So we came up with 4 possible prototypes, and Ms. Magno looked at all 4 and said they were all garbage, and we had to redesign. So we came up with 2 more better
was very
prototypes.
blunt, right?
And we got, this is the winning one. It's actually Xavier's prototype here. So it locks on like that.
Okay.
And then the students, instead of sitting in the desk all day, can spin it around and stand at the back of the room and keep their books and stuff down here.
That's great.
And with a grant from the PTO, we were able to buy enough wood so we can build her a set of 9 of these, which
Okay.
we're looking to start, I think, tomorrow.
Oh, that will be
We'll
terrific.
see if Xavier's construction team is up to the challenge.
Right, right. Well, thanks. That's great.
Yeah.
That's a great idea. And did she explain specifically why she was looking for stand-up desks? Or I know I have one, as I said.
Well, I think
which
that's
is-
what
yeah,
it was. I
yeah.
think people wanted it.
Yeah.
But then it was interesting because we got to have a few interviews. Xavier, do you remember what the different specifications that she really...
Yeah, so now the specifications that Miss Magno wanted was stability, so that like if you had a backpack on before class or after class, you didn't bump it over, and knock it off. And so what she thought originally she would like the most is adjustability, for it to be able to adjust up and down to different heights. But she found that stability and one size to fit all would be the best option.
Yeah. So I have a question for you because you just talked about, and I'm thinking of the future once again, what you might be interested. You just talked about things that a salesman or a designer would be, or an architect would be working with a client about.
Yeah.
So do you have any interest in pursuing something along this field where you?
Yeah. So right now I'm a mason.
Yeah.
And I like to build. I'm very hands-on.
Uh-huh.
So I want to do something in like the engineering field or something like that.
Okay.
And robotics and everything like that helps me out on like being able to work my hands.
Right. Think through the problem,
Yeah.
think through the design, fail and try again.
Yep.
So it's all good stuff. Well,
that.
thanks. Thanks for sharing.
Thank you.
All right, so we've seen a number of projects here, and I love them. I love, once again, the students. And the other thing I think we didn't talk about was the confidence that they're building, for
Yeah.
themselves. Not only taking those risks and designing something, the collaboration with each other, and then performing,
Yes.
which we always like to see kids do. So when we think about a class like this, those are the things we think about, not only banging nails or putting things together, but it's all the other skills that we want to teach them.
Yeah, really, it's the designing skills.
Yeah.
And, my conversations with engineering colleges and industry, I've taken courses from both of them over the summer. What they're looking for is not necessarily students who did well in their math class.
Yeah.
I mean, that's helpful.
Right.
But they also want them to have a creative side and be able to mesh both the technical and the creative
Right.
side, and then present what they have to say, both in an oral and in a written
Right.
manner. And if they can't do that, they're just not going to be successful.
Right.
It's not what the industry needs.
That's exactly right. Exactly
So
right.
it just comes down from the top. The industry is asking the colleges to produce this type of thing, and the colleges are asking for this type of student or looking for this type of student.
We just, before we talk a little more about that, we just showed last week the movie documentary Most Likely to Succeed. We had a
Right.
community event, as you know, and that was really the whole thrust of it, was about project-based learning, and we hear the words,
Right.
but this is certainly a great representation of that, your classroom.
Right. Well, I mean, I think what happens a lot of the time in any school, be it a high school, a college, an elementary school, is we compartmentalize the learning. So
Right.
we're doing STEAM, we're doing science, technology, engineering, arts, and math.
Right.
But we're doing them all in separate places with different heads, and we don't get a chance to put them all together in one project.
Right.
And that's really what's powerful.
Right.
But and I think what often gets left out of the conversation is the creativity. And that's where a strong art department like we have here at
Yes.
Dartmouth High is super important,
Yes.
because it can really support those creative students in
Right.
bringing that into a technical field.
Right. I'm glad you mentioned that, because you just used the word STEAM, and as we know, but some people may not know, science, technology, engineering, art, and math.
Right.
So for a long time, people have just called it STEM, of course, and you just talked about why it's important to bring the A
Right.
in, which is the artistic.
Yes, the creative. It's the creative.
Creativity, right?
Yeah,
Right.
aspect.
I think really we could create schools that are just called STEAM schools and do it all.
Yeah, well,
it all.
yes, they do that.
Yeah.
There are a lot of things our school does well.
Yeah,
So
yeah.
it's not just that.
Oh,
we
yeah.
have a lot of great things happening
Absolutely,
at Dartmouth High.
absolutely.
But that's sort of what's happening in the cutting edge of technology
right.
now is
That's right.
is bringing these other aspects of learning into it and making something greater out of it.
Absolutely. So, as we said, you just showed us a whole bunch of great projects. Are there some things you're thinking about that you're going to have to look at some funding sources?
Well, we're always looking at funding sources. I
Right.
just got a couple $100 from the Air Force,
Oh.
which is super helpful,
Yeah.
though the Air
Yeah.
Force feels like they could give me more than $200.
I would
but
think so. I don't know,
anyway.
though.
But don't look a gift horse in the mouth.
Yeah.
No. They're, that's to help with this RC Planes project.
Okay.
We get money from the DEF almost every year.
And that's the Education Foundation,
Dartmouth
right?
Education Foundation.
Right, right.
The PTO kicks in money all the time, and that's great. Because the thing is, thing about project-based learning is projects require consumables,
Right.
and it's an amount of money that we need.
Right.
So I'm always looking for different sponsors. The robotics team was partially sponsored by PTC, which is a large engineering
Okay.
firm.
Okay.
And a lot of these larger engineering firms are looking for ways to do their own outreach and produce future workers.
I was just going to
Yeah.
say that, yeah. The more they can help, the more they can be assured of getting some really good help
Exactly.
in the
That's
future.
their thought.
In the future.
Yeah.
So I was just looking at some of this. What do you think? We're talking about the future for the program itself.
future for the program.
If
Well,
you could create it from scratch, blank canvas.
Okay. Well, we're always trying to increase our capabilities here.
Mm.
So we're always trying to get new tools and techniques. We got a 3D printer finally
Oh,
really up
yep.
online and running every day, and that's great. You
Yep.
should talk to Jeff Martin about that one day.
Yes.
That's really neat. We're looking at
He
a
actually
laser.
gave me a little Indian head. So yeah,
Right.
that the
Yes,
kids
he's
made.
got all
Yeah,
sorts of
yeah.
neat things he made.
Yeah.
we're trying to get a laser cutter going. I'd like to upgrade that CNC.
Yes, that sounds like a good thing. Good
right,
plan.
stuff like that would be really great. I'd like to do bigger, more expensive projects. If I can find a funding stream to do drones. But it's just that's an amount of money. Satellites. It's a thing people are doing. They're shooting up their own satellites these days. You can't shoot your own rocket off, but you can hitch a ride on a Chinese rocket for fairly cheap. And you could have a DHS satellite. How neat would that be?
Right.
Boats. I mean, we live right in this maritime community. I'd love to get into some boat building stuff, but there's not only money, but like, where do I put them?
Yeah, sure.
So they're really big things. So we'd have to, cross those bridges to do projects like that.
Right.
Definitely.
Right. And you mentioned again the drones and whatnot, and I'm thinking, my goodness, I suppose you're in contact area businesses or whatever it might be that.
Yeah. I mean, people are into it. It's an idea. I just, sort of have to latch onto it and.
Right.
Right. You know how grants work. Like
yes, I do.
As many as you get, you also get refused from. So we're in that process.
Absolutely.
But let me say the other thing I'm hoping for the future of the engineering department, robotics team, et cetera, is some gender equity.
Okay.
My classrooms sometimes look like it's 1953. It's crazy. And there's a lot of reasons for that, but there are also a lot of solutions.
Right, and you're right. And if we can continue to grow our girls into these kinds of programs, it would be helpful. But what is the answer?
Well, I think the answer is there's a lot of different solutions, and it comes from a lot of different places between administration, teachers, guidance, kids coming up through the lower grades, community, family, peers. Like, there's so many different sources. But at the end of the day. The engineering firms that I've talked to are looking for female engineers, and it's simply because they're realizing that 51% of their consumers are female, and they're going to miss design choices and opportunities if they have, if they don't have a very wide range of backgrounds and abilities on their design teams.
Right. So it's very important.
Yeah.
Well, I think we're about out of time, and unless there's any last things we didn't talk about, you want to.
There's a million things we didn't talk about,
I know.
But you'll see us out in the community building awesome things, flying planes.
That's good. And if people see advertisements for a competition, whatever, they're free to come by and take a look.
Definitely. And if there are any parents or community members that want to get involved, I have people come in all the time, electrical engineers from the Navy, RC plane specialists,
we'll get that out on our
reps.
Facebook.
Yes,
we'll get that on our Facebook page and say, hey, give the high school a call.
Yeah, come in, see what we're doing, show us what you're doing. It's super, super helpful and nothing like an authentic experience.
All right. Well, thanks, Sam.
All right.
It was great being here. Thanks for showing us all of your fun toys, and thanks to your team. Come on over, guys. Come on over and get a last look here. We love our students.
Don't forget the robot.
All right. So this is Dr. Bonnie Gifford, and again, we are on location at Dartmouth High School as we have our last guy coming on over. We hope you enjoy this session of Dartmouth's Got Talent. And again, if you have any interest in coming on in and offering some expertise or some resource funding or whatever, let us know. Call the high school, and we hope you enjoyed the show. Have a great day.